Now that we've used this method of dimensional analysis or stoichiometry on a more common example, let's look at how we can use it in chemistry. And we'll go back to the original example where I asked you to go to the back room and get 4 moles of lithium. And let's use these rules to figure out how to convert it. So step number 1, write the given number over 1 as a fraction. So we have 4 moles of lithium, and I'm going to put that over the number 1 as a fraction. Step 2, multiply by a new fraction. So times new fraction with the old unit on the bottom and new unit or wanted unit on top. So the old unit that we have here is moles of lithium. So I'm going to put moles of lithium on the bottom. And on top I want my wanted unit. And remember that here we are converting from moles to grams. So on top I have to have grams of lithium. Don't forget to put both the unit and what element or compound that we're talking about. Knowing what compound we have is going to be very important later on when we do this math with multiple types of compounds at once. So we have 4 moles. Now we have the second fraction, and we have to check if our units cancel. Moles of lithium cancels out with moles of lithium, and we are left with grams of lithium, so that's correct. We now have to plug in numbers for the fraction. So I have a fraction with grams and moles in it. Well, you may be saying, I don't know what this relationship is. Well, if you ever have grams over moles, or moles over grams, this relationship is the molar mass. The relationship between grams and moles, or moles and grams, is always the molar mass of the compound. And this should make sense because the unit for molar mass is grams per mole. It tells you in 1 mole how many grams that sample has, what the mass of that sample is. So if we look up the molar mass of lithium, we will see that lithium has a molar mass of 6.9 grams per mole. 6.9 grams per mole. So how does this fit into our equation? Well, think about what this unit grams per mole means. This tells you that there are 6.9 grams in every 1 mole of the compound. Whatever unit you actually say first is what the number goes with when we do stoichiometry. So you can think of when we say our unit, whatever unit you say after the number, that's what the unit goes with. So we have 6.9 grams per mole. 6.9 will go with the grams. And that's the number of grams in 1 mole of lithium. We can then solve. So we end up multiplying across the top, multiplying across the bottom, and we get 27.6 grams of lithium. And note that our unit at the end matches the only unit that hasn't canceled in our stoichiometry. Let's now do one more, but this time let's do it for a compound. So let's do water. And I will give you 50 grams of water, and you need to convert that to moles. How do we do this? Well, step 1, put the given number over 1, and then 2, multiply by a new fraction. 3, old unit on the bottom, our old unit is grams, so grams H2O. The unit we want, I said we're looking for moles H2O. And then next step, cancel units. So grams of H2O cancel with grams of H2O. Good. we are left with moles of H2O. We have moles and grams in the same fraction, meaning we must use the molar mass. The molar mass of water is, well, hydrogen is 1.01, but we have 2 of them, so 2.02 plus 16 gives us 18.02 grams per mole. Remember, that's hydrogen plus oxygen. And the number always goes with the first unit you say, 18.02 grams per mole. So we put 18.02 with grams. And that's the mass of 1 mole of water. Notice how with this method, we don't have to worry about, well, do we multiply, do we divide, what's going on? All we have to remember is old unit on the bottom, new unit on top. If our units cancel out, the math is done for us. So now all we have to do is multiply across the top, multiply across the bottom. We end up having to do 50 divided by 18.02. So 50 divided by 18.02 when we multiply across the top and across the bottom. When we do that, we get 2.77 moles of water.